Hello everyone, and welcome to Network Pips. In today's class, we're going to talk about version control with Git and GitHub. Our learning objectives for this class is going to be introduction to version control, understanding what version control is and how we can use it in software development as well. After that, we're going to understand the concept of Git and they also head on to our browser to set up a GitHub repository where we can centrally manage our code. After that, we're going to understand the concept of branch and also merging and resolving merge conflict as well. So having said that, let's go to the business of the day. I remember when I used to work with AB. Remember when I used to work with AB, we used to back up our devices monthly, maybe our routers, our switches. So we will SSH to this device, that's remotely log into this device and do show running configuration because it's a Cisco device. We'll copy this configuration and we'll paste it on a notepad and save this file with the device host name and preface it with the date at the point of backup. Then we'll save it on a notepad in a folder as well, and save and give the folder, say the name of the folder as date at the point of backup as well. Now, the reason why we do this backup monthly, or the reason why we take this backup of this device is because of when an issue occurs that might take a longer time for us to resolve, instead of troubleshooting to find out the solution or the issue or resolution of this issue, we can quickly go back to the previous known working backup that we took maybe last month and quickly restore this configuration, and everybody thinks that, oh, the IT did a fantastic job. But yeah, we actually did a fantastic job because we always keep our backup up to date. Then another reason why we take this backup is when a disaster occurs, maybe the device crashed, we can quickly restore this configuration, the previous known configuration, because we don't want the point where we can start making this configuration from scratch again. It's going to take a lot of time and it's going to cause a lot of downtime. So this is similar when it comes to software development. In software development, our code is being stored on a central repository, and our developers will pull or fetch this remote code into their local workstation. So you can imagine these developers working on a large project like maybe Facebook or Instagram, and they are all maybe some of them are working on the back end, some of them are working on the front end, and they are making different code changes and adding some features, maybe changing the notification icon from blue to red, and they can also, once they are done, they will push this code to the central repository, and the central repository can resolve any conflicts that can happen between between the developers' code changes. So this one of the repository will have one of the GitHub. One of the repository we have is we have GitHub, we have GitLab, we have Bitbucket, we have AWS code commits as well. So basically, version control is a system enables us to know, keep records of our file changes over the time, and also helps us to promote collaboration and track changes and the facilitate management of this project history. So, understanding how Git works, Git is more like a Linux command, which we can use to track file changes on our system, So, and it integrates very well with remote repository like GitHub and also GitLab and some other ones as well. So the concept of Git is we're going to have a remote repository where we are going to store our files, our code, and it will enable us to fetch this code to our remote repository, so we can be able to pull this code, and we can be able to push code to that remote repository, and this promotes teamwork. Now, we can also initialize a local repository on our system and push it to the remote location as well. We can do this using the command git init. This remote repository consists of three main components. It has a working directory, it has the staging area, and it also has the git directory as well. Now, after we have done making changes on our file or on the directory, before we commit these our changes to the remote repository, we're going to use the command git add, to stage our changes, all the changes that we have made. Now, in this particular level, it enables us to selectively choose what kind of files or what kind of changes that we want to include on the next change as well. Now, after staging our files, or after adding this our file to the staging level, we're going to commit this our file to the remote repository using the command git add. So git commit. I mean to say, git commit gives us option to add a comment on our commit. So how this comment is going to tell us what kind of changes that we have made on this file. Let's say we fix a bug or we add a new feature, and when an issue occurs and want to restore to a well-known working version, with that comment that will add on that commit, that will be able to tell the next developer that wants to restore this code changes and what kind of code is restoring as well. So git commit is just like a snapshot of the project at that moment. That's what it means. And this includes the changes that you have made and reference the previous commit as well. Then branching. The concept of branching, allows you to create a copy of another branch. This helps us to the idea of this is when we are working on a new feature or a bug fixing, we want to make a copy of the branch that we are working on, so we won't conflict with the original branch. That's the essence of branching. Then branching are lightweight and they can be easily be switched in between, and the branch can create branch, you can delete it, and you can merge branches seamlessly. Now, when you are done making changes to your branches, you are going to combine these branches together, and your git your version control system knows how to automatically resolve any conflict that can arise between these branches, and whichever one that you cannot automatically resolve, you are going to manually resolve these changes. Now look at this thing this way. If let me say Nneka over here has been coding on her system and hasn't been committing all the code changes that she has made to the central repository, and let me say Ebuka here has been committing, and maybe Chika here also has been committing as well. When Nneka wants to commit her own changes to the repository, what will you think will happen? There will be a conflict because the code version of Ebuka and the Chika here has also differed from Nneka's own. So there's going to be a conflict, and she has been storing these code changes on her system for a very long time, and the conflict is going to be much. It's going to take a longer time to resolve. There will always be a conflict sometimes, but the idea of it is you continuously integrating. That's where continuous integration comes in. Continuously integrating your code changes to the central repo. So even if they have a conflict, it can be quickly resolved. It might be just one line of code or 2 lines of code, but this type of Nneka's own now might be the whole script itself. himself. So so that's why the idea of continuous integration, integrating your code changes to the central repo, is always advisable, is always recommended. So having said that, that will bring us to the end of this course, and in the next class we are going to look into how we can set up a central repository in GitHub, and also put this repository on our local system. So don't forget to like my video and subscribe to my channel. See you in my next class. Thank you.